Hi everybody, good morning. I'm doing some rooms I'm missing. I didn't do in SOC level 1. Which one I'm doing now? Uh, I don't know which one I'm doing. Man in the middle. Web security monitoring, Linux security monitoring, malware threat detection. Huh. I thought I didn't do this room. Where are you? Pyramid, the sufficient network traffic wire shark. Network data. Don't tell me this room is not part of the path. Detecting web attack. Which this room is? Detecting web shells. Yeah, this one. Detecting web shells. I thought. So this is a premium room. If someone doesn't have subscription, you can read there. Now, explore web shell detection and analyzing logs, file system and network traffic. Of course, if you're doing CTF or red team, there's always you try to upload a shell and things like that. But this one is more about how to detect it as a SOC. Knowing how to detect web shells is an essential skill for SOC analysts. An incident responder. Web shells are a common technique attackers use to gain an initial foothold on target system. They provide remote access, enabling various actions later in the attack chain. In this room, we will begin by refreshing our understanding of web shell, then dive into detecting technique using a variety of logs and tools. Learning objective, understand what is web shell, detecting web shell activity through logs, file system and network analysis, understand common tooling in web shell detection, some prerequisites to understand some HTTP request, enter to log analysis, some initial access and response. Okay, this is introduction task 1. Of course, the lab they give us in part in next one. But we can start for task 2, web shell overview. What is web shell? Effectively detect web shell. It's important to understand what is it. A web shell is a malicious program uploaded to target web server engine or enabling adversary to execute command remotely. Web shell often serves both initial access method and persistence later on. For example, once access has been gained, a compromised server attack can use an web shell to move through the kill chain, performing reconnaissance, getting privilege, moving laterally, exfiltrating data. Yeah, usually that's how you start. For example, here we have below is a simple example. For example, this attacker, for example, upload this LWE shell.php. This is an example of this server, for example 10.10.10.100, and you can see the form. You can run the command and give you exactly the response. Web shell deployment for attacker to upload or execute a web shell, a file upload vulnerability, because usually when you find the attacker usually looking for a page where you can upload images, profile pictures, things like that. Misconfiguration, prior access to a system is required. These vulnerabilities arise when application fail to validate file type, execution, content, and destination. For example, here a simple website that allows you to upload your pet photos. The website is intended for storing images. However, if developer insecurely and attacker may upload web shell like share.php, and because there's no checking if this is an image or not. Example in the wild, for example, real life scenario, for example, what's this? Hafnium, a Chinese based APT uploaded DICE PX web shell to Windows Exchange server. I heard about this, yeah. This one web shell, where is that Hafnium? Is a likely state-sponsored cyber espionage group operating out of China that has been active since 2021. So if you want to read about it, The next, once the web shell is successfully deployed, Honeycomb continue to execute command, perform reconnaissance, dump credential, further establish persistence. Another example is this Conte ransomware threat actor abused a similar vulnerability in Microsoft Exchange, which allowed them to upload a spnet client underscore log. I think I remember these two. The Conte, yeah, it's another one. Okay, let's first for this one is just introduction, which MITRE ATT&CK persistence subtechnique are web shell associated with. We did open that one. Server software component web shell subtechnique is this one, so you can just take this one out as an answer. So we can go straight to the labs. What file extension is commonly used web shell targeting Microsoft? Because it's Microsoft, so the extension would be .spx. Now, anatomy of a web shell. Anatomy of a web shell. Legitimate function abuse. Web shell relying on the abuse of legitimate function with because if you do PHP, most CTF now they try always use PHP and blame PHP. Most PHP programming they will use usually a framework like Laravel or something. Most of stuff get protected, but in any case, shell exec system pass through all this. Most even when you have web server, they block this function. So under the hood, for example, if you want to do these things, you can see, for example, you check the app, like for example here you can see always check the CMD. For example, there's like this get request, for example, store the user by command, execute the command. For example, here it gives you this an example, get the command, then execute shell exec, you put that's the shell behind, and that's how usually you call it from the web server through a get request, for example, variable cmd, and that's how you detect it in a log later on. Now, web shell varying complexity capability, they can range from simple one linear that executes command via URL to fully featured interface. These fancy shells out there. A web shell in Accent, for example, now they give us these examples. For example, if we go to our let me close this one, we don't need it. So this is the lab that we have now. Um, for example, here it just give you an example of a web shell that an attacker uploaded. You can see it mean was uploaded in directory file, and you can see here you can just start. For example, ls, it tell you this. Of course, most web shell when you do who am I, you always get it run under web server. So basically, because here if a server is secure, you can do too much, because to do privilege escalation from this one, if the server is very protected, basically it's a dead end. So don't assume you go to web shell so it's the end of life. So here we have that web shell, and here take run who am I, we already said w data, and then data, let's look for the flag. The flag we can see it because if I do -la, I can see this file called log fly, so you can just cut it here. This is just simple introduction to show you what we have here. Remember, this room goal is more about detection than it's not a red team style. For example, here task 4 log based detection. Now we go into logs. Web shell rely on the abuse of web servers, so web server logs are natural place to start our hunt for evidence. We will explore what it look for popular web server. For example, most Apache, you get access log, error log, the remote log name. Yeah, usually we check this. Usually, for example, you can see always Apache. You have the sender, the IP, the time, and then request get post request. You say the request line, then 200, for example, or 400, wherever the response code. Response size, and then whatever the agent. Basically, you can see them here. If we go to, let's be done with this. For example, if I go to this machine and you see the var w logs, no, the var logs Apache. Where's Apache? You can see for us most interested log is the access log. If you go to head access, you can see basically what happened. You have the source IP, the time. You can see this, the get or post request, put something, the endpoint that the browser or the user, wherever try to access. That's the header. You can HTTP1. This is also important. It mean 200. It mean access, the size, and whatever the agent. I can see is a Firefox. So basically that's how we detect them. Web indicator and use HTTP method or request pattern. For example, repeated GET requests in quick succession could mean attacker is probing a valid place. We check this in when we go in the lab. Post request to valid upload location following repeated GET. So it means uploading a shell then try to execute. Repeat GET or post request to the same file could indicate web shell interaction. Yeah. For example, get retrieve resource, post, submit something, upload, interact with web shell, put, upload. Usually most of the servers they block this. You can just use it. Delete, remove, option. The option you can because it tell you what option the server had. Simulate to get but only return headers. Let's work, for example, here it give you an example. Example is clear. For example, here you can see get request. We can see the 404 it means not found, and then it's 200 so you find the endpoint. So you didn't find the first one, two, and then you find, so more like a WordPress site. The 404 means not found, so mean still in meriting. Found the form, so then he found the form where to upload. Then here's a post request here, so it's submit a form. Now after you submit, now is web shell access, now interacting with shell. So the logs will look like that. So it's, you can see altered to user agent. For example, suspicious user agent IP. For example, you can see this not a norm, try to masquerade in an old agent. You can see curl, for example, or wget, for example. Query string, for example, if you see there and you see this is PHP usually, or you can see the query something like query how am I, query something, command. This is and of course you have cyberchef to decode in case you see base64 because sometimes shells they're using coding. Now the next one is missing a referrer because the referrer show where the before you go to that page where you came from. Sometimes is a legitimate reason for it for privacy, but sometimes like browser can block it for directly. Sample suspicious web requests. Knowing malicious for you, maybe you can find the IP is malicious. The time is strange because, for example, it's late. It's not usually, for example, most of client access certain time. Post request with a search query string to a malicious file, like for example, things like that. You can see there suspicious user agent. For example, here the curl. Normal people don't just use curl to go to your website. Audit D, yes, audit D is when in Linux to, for example, here they say you can, if you know audit D, because it read audit log, which determine what is logged in audit log. For example, the key web shell. Let's go there. Let's go come back to this later on Apache. Let's switch to root. Search minus k web. I think this key doesn't exist. Web shell. Okay, chmod 0. So I don't know why I didn't have right permission. Audit log, and then we have no much. etc, where are you? Audit. We have web watch and we have web shell exec. No, so we don't have what TryHackMe is telling us. So why TryHackMe is using this web shell here? Let's see. search minus key, we can do the web watch. What exactly, if you look here, web watch is checking the var.w folder for any file change. So I mean this one is tracking web shell if someone upload a web shell, and this two, the web shell exec is user ID. Anything that is executed by this user 33, and then who is user 33? Cat. This is what are you? Cat etc passw. Who is 33? 33 is our friend, the ww data. So we know what these things we can. This one interact if someone upload or changing file in the var.w. This one is access. So anything run command run by that user w data. So we can start with that. Our friend, the watch. The watch is smaller. You can just scroll here. Proctile, let's solve that proctile things. Just put so we can read it clearly. Minus I. That's Apache start. Then you can see the W content folder upload. Something changed here. I think that's a normal Apache, but there's something. Wait plus W content uploads. It's referring to the upload folder. You're not supposed to show me that web shell, or I can't see. Believe me guys, WordPress content, it's referring to the upload folder. The key is website watch, that's the user. It's talking about WordPress sites, so the W content upload folder, but it only detecting the folder itself. So it tell you that this folder something changed on it. The upload change. So it give us sign at least. I thought we can see. We'll come back to this. So let's come back to this one later on. We'll do it in practice. So we have the web shell. It said detecting web shell effectively require correlation multiple log row. Suspicious post request in weblog can be linked. This thing, the create and the access. Access is a running command and things. This one create files in the directory. You can do. You can look for them. I think syscall create doesn't have. This log wasn't done, or what was the next one? X. I always forget. CVE, XE, XE, CVE. Oh, you don't know, we have too many of them. So this one you can see it's the W data is running, and then you have the proctile. I can just do this grep minus I if I want, and just grab that the command. The command is under this line. And then I can get all the command that attacker is doing, so I can see who am I, things. This room is not about ODD, so I don't want to confuse everybody, but let's continue. So what is the part of the URL that associated value to parameter and can be a valuable indicator with shell activity? Chun, 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 chun. What is it? No, I forget. It should be that little things in the string, the query string, they call it. If what they call it? User black suspicious. Because what? What the query? This little things. What they call this? Not this one. The one that has command. Yeah, these things. The interaction with the shell. This part. Oh, they call it query string. Okay, let's for a moment. Then what ODD syscall will confirm that file was written to the disk. Suspicious request to the syscall is this crit. I don't know why they call it crit and not created or something. I don't know why our ODD doesn't show the crit one. Doesn't have. Let me do something. How about our friend? It doesn't have it for some reason. File system analysis. An attacker web shell must be. What's the beyond logs? Task 5. File system analysis. An attacker web shell must be stored somewhere. Analysis web server file is crucial to identifying uploaded web share or locating file modified to include the web shell payload. It should be noted that some platforms like WordPress and Django store page content in a database rather than a file system. So malicious code may be injected into posters, themes, and all of that. Okay. Apache is var WHTML, Nginx uses share engine. We're not doing Nginx. Our room is written in Apache. Even if a customer path is configured, attacker can guess because it's usually upload image names are standard. That's why suspicious or random file naming, for example, can be used by attacker to evade detection. Be on the lookout for names that deviate from standard application file. Monitor file with executable extension like PHP, JSP. Be on the lookout for double extension. This is like trying to bypass your filter. Helpful compound is like always find something like in newest, for example. Let's not. For example, let's see apply it in our server. Let's see what this will give us if there is anything. I'm citing Apache. Basically, here it said find in the var w init file type f a name that has .php, for example, from the 1st July to 1st August, so 1 month change. This one will tell me this is like we got the whole chiller. That's the time when WordPress was installed, I think. So basically, the time range is not good for us, but it just show you what it is. Next one is of course this one is grep. Just grep is our friend because you look for any funny commands that grep is fast and can search everything. Minus no, we are not in w content, so we can need to var WHTML. It's in WordPress. Didn't find anything really. How are you? Minus R. There's no eval there. Okay, we'll check later on. W content upload. Now I'm curious. It is var WHTML WordPress. How is it up? No, WordPress p content upload. What? You have a line piece there. We have that our shady shell that, but doesn't use eval. Maybe that's oh, it doesn't use eval. That's why the grep didn't find it. Okay. Let's go back. Network traffic analysts allow us to go beyond logs. Here's Wireshark and things like that. Unusual SP method request pattern, suspicious user agent and IP address. We talk about this. Encoded payload base 64, for example. Malicious code or command in request bodies expected for protocol and expected resource usage. Web server processing point. Yeah, this is you need to check parent and child processes. Packet capture providing important detail can be crucial in confirming an attack. For example, pcap showing post to upload while you post into there. Web share, this is usually in Wireshark. You go http.request.method and you look for post put like when you have a CTF and tell you what's the username used or password, so it's a post request. You just put a post and get whatever the for example here looking for just PHP, you go request URI used to locate unusual outdated user agent. Here's a complex list. This is normally not about Wireshark, but it gives you an idea. And because Wireshark, when you do follow request, it shows you all this child, then you can see the command there. So if you have a room that run in Wireshark, but for us it's not Wireshark. Like, so what's the command we use to locate? So it would be find in var w type file everything in PHP. Oh, to locate in find a type file. I'm confused now. What the hell am I missing? Oh, the name, eh? Sometimes I'm just confused. Type file dash name anything.php. That's supposed to be that one. And then which Wireshark filter method will you use to search for? That's a request method type. Request no type request. I do a couple of Wiresharks. This one I always use it. Method request method methods. No. Equal. If you're looking for put, you do that. You usually don't use what? Type request method. Oh, HTTP request method. HTTP. Sorry, guys. Now I'm confused. HTTP request method. Now we have investigation for this in task 6. They give us you have been called to investigate potential signs of compromise on WordPress sites. Suspicious activity has been reported, and your goal is to analyze available logs to identify indicator of web share usage. You can do SSH, we can access that site. They give us you have been provided Apache log, repeat a suspicious request in PHP file, unusual agent. You can also do 4x4. Okay, let's go to our lab. This is our lab, so we have our Apache log. Leave this one, we need it, we come back to it. We know our friend is this. We can go here to they said to us there's we have two files. What's that inside files there? that web shell. We did example before, but we have WordPress. So usually when you have a WordPress site like that, usually it's always good to look for a W content folder and upload. And here you can see our friend there. We'll come back to you later. So this is not supposed to be here at all, because WordPress doesn't put file like that. It put them in folder with the year, like 2015 and the month. So this and all of this, that doji character, not supposed, all of them not supposed to be here in a normal WordPress structure. Now, if we go to our access log, of course you can see it like that. It's too noisy, but for example I can do, how about if I will grab 44 from access log. 404 it means not found, so if I go start looking from the top, you can see now something is very clear in this log, and you can see the enumeration happening here, looking for different things, so we know what the person is looking, secret share, script admin, wherever, and you can see the same IP address. This is giving us high probability that's the attack IP. Why someone go to a wrong file? If you go into the website, you click in the menu, you don't just click things. So that's why you said all these not found things. So this is give us indicator that's what is the IP address, likely this is a high potential. What is the first directory that the attacker 645? You can do reverse things, and you can just do I can just minus v the 400, for example. I just want to see, and just go, now just to, for not there, just movies, I'm more looking for the 200 and just get the head only. So let's see what exactly, but also no, hold on, because if the log is big, I need that IP. What's that IP we got for, I need that, so we now know probably the attacker is this one, so we can we can be fancier, we can do this minus E. I need that IP. Oh, I don't think we can do this. With that IP I'm confused now. Usually you do a point and you go star and you say I need also for 200. Not sure this one will work. It did work for some reason. Let's not get the head, let's see the whole things. Okay, so now it's like everything is red. Basically what I'm telling him is get me the IP of the attack and then anything, and there's 202. I'm interested of this 200. So if I look, that's why I'm using egrab here, so that it tells me look for anything that has this line, that IP of the attacker, and also looking for this 200. So apparently he got what? That's normal. It mean he went to the main website. The next one he got WordPress. You can see it's 200. Look for the agent. It gives you a sign, but it's a shady agent. So you can see it confirms is an attacker because of the agent. See the agent name. So we know the first point that he got is this one. So we can go there. Now the next question said, what is the name of the PHP file the attacker uses to upload to the web shell? You can just follow the 200, because the 200 will tell you exactly what he's doing. He said login redirect. He's trying to do the login page. Now he's going back to WordPress, the content, the upload. Now we found the upload. Then for some reason he got the upload form. I don't know where he got this upload form from. I want to see this, where it came. This is not a normal it's not a normal WordPress thingy key. It's not part of WordPress. Where he got that form from? Oh, that's why we didn't find it in the audit D. Remember when we did the create doesn't exist. There's no this file. Where he got this file from? The logs doesn't show this part. It's not there. Okay, that means that's why the explanation that room doesn't make sense to me, this part here. And then you can see what's the question again? What is the name of the PHP file the attacker used to upload? So the attacker you can see is calling a file. So the upload was done through this one. So this clear indication of this. So we can answer this question for now. That's why we didn't find it. It's not full log this run. What's the first command run by the attacker using the newly uploaded web shell? We can see them. We can get all information there, or you can be the new upload share is this. So we can just do this. We can go to normal grep. We don't need to go fancy grep here. Just a normal grep, and then we can continue listening to this. You can continue. You can see it has CMD there. So you can do this, or you can just more cleaner. You can just I want to do what in CMD. You don't need it, but you can try it. So it give you this. How to be fancy. To just get that to be fancy. How to be fancy in these things now? I forgot how to do that cut. No, let's not be fancy. Let's just the first command. That first command is who am I? You can see it. That's the first one. After getting access file via the web shell, the attacker uses a command to download the second file to the server. What is the name of this file? You can see the commands here. Uname, ls, then you have a cut pass w, and then you do it twice, okay? And then you can see wget line piece. So he downloaded the line piece from his file, so we have that there. Remember guys, all these commands we already saw them here. In ODD you can see the my file, the uname, and have the lshome, the cat pass w, we did it twice. And then you can see the command sh. So if you have an ODD, it's easy to cleaner than look into this one. So you can always where are you? You can always check, and you can see the command here. It come cleaner. You don't need confuse of decoding like here this one. Like in this one, you can see how it look. Encode here it's cleaner. You can see all the command next to you, so you can see it's downloading that line piece. And because here, remember here we're looking for all the access of the key. Remember because the ODD, why is that ODD disappear? Okay. So you can use the ODD if you want to solve the issue. Just look for the logs and play around them. The next question is the attacker has a hidden secret within the web shell. Okay, the web shell, we know where is the web shell. That's the web shell. So we can just go to w content uploads, so we know where is it. So we can just go to w content uploads, and we can see it's cat shady shell, and it does the hidden flag. Yeah, so this room is more, we want you to be comfortable running command line and running between files and folders and things like that. So this room is more an introduction. Now, task 7 conclusion. In this room, we covered how to detect web shells through log, file system, network, and behavioral analysis using a combination of native OS utility and specialized security tools. By working through logs, sample, and simulated attack scenarios, we developed a deep understanding of how web shells behave and how to uncover them using a real-world scenario. And we completed the room. So yeah, I think the other rooms later on they all use ODD. It's faster to then. Also, if you learn how to use grep and cat command to clean the code, I forgot that cat, to be honest. This is one of the rooms they talk about it. Then you're done. Okay, we're done with this. Thank you guys very much, and hope you like it, and have a good day.